Thank you, and welcome you all here. Yeah, like title says, we're going to talk about a little bit the financial side of the AWS and what might not be so obvious about that. Yes, so my name is Petri Kallberg. I work as a CTO for Nordcloud Finland, and with me I have here my colleague.
Michal Czerwinski.
Okay, let's take put the mic on.
No? All right. Michal Czerwinski, working as capacity service lead in Nordcloud.
Yeah, and what we're going to present is kind of based on things we have seen on our customer base. So we manage like about 1 million or so of the AWS capacity on a monthly basis. So you can imagine all kinds of things are happening within that. With that introduction, what is this FinOps thing? Yes, not much better. Yeah. Thank you. After all, so.
Right. FinOps, what it is, it's basically the whole culture, organizational culture, that we can split into 4 phases. So to inform, optimize, operate, and repeat afterwards, as it's a constant process that never ends. First of all, inform. So visibility, it's quite important thing to know what you're spending on. Without that, you cannot proceed to anything else. If you don't know what you're spending on, you cannot optimize it. You cannot take care of the waste or underutilized resources. Then it's important and vital to make sure that everything that you do regarding cost and further growth is data-driven, so that you have some basis. And after all, promote best practices. If you want to split cost afterwards, charge back internal units, make sure that you will be able to do that. And optimize, so manage your waste, as in if you're using, for example, EC2s, let's think if you really need, for example, extra large size, perhaps medium is going to be just fine. And that's also about right sizing, so picking the instance or database or EBS volume that will suit your needs. And utilize reserved instances, savings plans, so if there are some steady loads, make sure to squeeze everything that AWS has to offer. Right?
Yeah, and with that, let's proceed to the first topic, which is going to be the kind of unsexy, but still probably one of the most important. So how you manage your waste in AWS, and what we mean by waste is just about any kind of resources you have deployed, but have no practical use anymore. It can be like a leftover EBS volumes, snapshots that no one knows where they came from. You have allocated IP addresses that are not being attached. There are idle load balancers lying around just because you wanted to have like a static endpoint for one of your services, but the services were already gone, or most commonly simply kind of underutilized capacity in typically like EC2 or RDS would be like a perfect example of this. EBS volumes, yeah. You might think that, okay, how this actually happens? So how people left these things lying around in a large quantities, and it can actually happen very easily if you don't kind of have visibility what's going on there. You don't see the capacity bill and don't actively follow on kind of resources you have deployed. You may like build a new AMI and by accident uncheck that one checkbox that says, yeah, I want to delete my root volumes when the instances are deleted. And if that's missing every time your autoscaling kind of spins new instances and shut them down, that leaves the volumes lying around. And with active services, that can cause you quite a lot of waste piling up very soon, and somebody needs to kind of actively monitor on that. The other way, of course, is like over-provisioning. So if you are creating too large volumes, or more importantly, you kind of allocate IOPS for your workloads and don't really need them. They can become quite pricey. Yeah, and once again, the key thing is kind of having the metrics data available. So, for example, how would you know otherwise that do you use the IOPS you have allocated? Other examples of this waste, yeah, like you created a backup procedure that takes a snapshot or every night or even every hour of your important data, but at the time it was very hard to decide how long I'm going to need this, and then it was kind of left undecided, and no one ever came back to that, and suddenly you have like a year worth of snapshots that no one knows. IP address is probably not so big issue, more like an issue from the operational point of view, since you have typically quite limited quota how many elastic IP addresses you may have, and you don't want to use that for things that you don't really need. Load balancers, as I said, people tend to have this idea that, yeah, we built this nice pattern that we provision a load balancer, and then we build our service or microservice behind that, and that load balancer is kind of nice static address for us, and so that will stay there all the time, and the services behind it will come and go as you do new deployments. But at some point, you moved on. Your service was changed to use containers, or went to the Fargate. You took Amazon service mesh into use, and those load balancers were left there, or simply you kind of replicated that model too many times. So it was fine when you had 1, 5, or even 10 services, but suddenly you have like 50 services and 4 environments per service. That totals like 200 load balancers times $20 a month for case already there. Maybe you can do it cheaper. And then this EC2 RDS, that's probably where the most of the money in kind of standard case are. So low CPU usage. It's not uncommon to see that, okay, the average CPU usage across the whole your EC2 fleet is somewhere in single digits, so like non-existing, basically. There might be your production workloads that are kind of quite okay in that sense, but then there's a huge number of kind of lower environments that are rarely used at all. For RAM, not all people have any metrics at all, so it's kind of just a wild guess. Do I really need this big instances, or could I maybe do with a smaller runs and then just scale it up when needed, adding more instances. One easy fix for this in many cases is upgrade to the more recent generations. So typically you get the similar compute and memory resources with less price. So it's kind of easy win, of course, keeping in mind that sometimes this is like a moving from older family to a newer family requires like changing maybe your AMIs because your kernel doesn't support all the new network drivers or whatever. But overall, should be quite straightforward thing to do without any kind of application level changes. RDS is probably especially sticky in a sense that when you create a database, yeah, that's that's kind of holding your state there. So you don't want to lose that, and then with that it becomes a difficult question that who knows, is this needed, and if I delete it or remove it, what things will break in as a result of it, and similar kind of IOP type of questions, of course, as with the EBS. With that, moving to cost optimization, this is probably kind of the basic stuff. So scheduling and auto-scaling, everyone knows how it works, but surprisingly few people actually do it. So idea, for example, that you would shut down your development environments during the non-office hours would easily save you like 50% of your EC2 capacity bill, just like that. But I guess there has been like too many bad experience that we shut it down something and then it didn't start up perfectly when people came back to work next morning, and because of these kind of experiences, you said, I'm not going to take any risk, and I keep everything running. It's going to cost me more. Maybe the better answer would be that let's figure out why it didn't start, and let's get it fixed. It would not only allow you to save in your AWS capacity, but it would actually eat some of your technical debt, which is there by definition if it didn't start again. So kind of good in more than just savings your running cost. Similar thing with the auto scaling. Typically you see like your stateless web application front end using the auto scaling quite nicely, but not even that in kind of all of the cases. And it needs the little bit effort to make sure that we have like stateless workloads, and yes, the new instances will start and they don't have too many dependencies outside of your the things that are in your control, because that's gonna bite you back very very badly when some of your dependencies is gone, and then your auto scaling suddenly cannot do anything more than scale down, and you will scale down to the bottom and cannot get up anymore until your problems are solved. So kind of easy, but still can be high risk items, so would require quite a bit testing, I would say. Then the similar concept for S3, for people who actually store a massive amount of data in S3, this would make absolutely sense. If your bill is somewhere in tens or a couple of $100, maybe not so much, but there's like a big saving opportunity moving from kind of the high-end storage tiers to somewhere more appropriate for your use cases. Like if you don't, if you can suffer some data loss, so your data can be recreated, so it's like temporary storage. Why don't you go down to the one zone model and save some money by doing that? And on the other hand, services like Glacier can actually add new features for you, so it's your write-only storage where you can dump your data that you don't actively use anymore, but there might be some regulators that say that we must keep this for next 10 years or whatever, and it's better safe there and cost you much less than in active S3 storage levels.
All right. Regarding also storage, it's quite important to use proper storage for your use case. We had one customer that basically stored PDF files on EBS volumes. Simply by moving those PDF files to S3 would save them about 30K a month. And that wasn't that hard, yet they had an issue with doing so due to usage of additional layers of applications. So then again, it might look easy, but sometimes due to the structure of the applications that you use, might not be. Okay, moving on further to spot instances. Those are quite a good thing if you would like to try out new instances or that you're developing a new project application. Those can be up to 90% cheaper than on-demand prices, but you need to remember that those instances can be terminated at any time with 2 minutes notice. So it's either for testing purposes or for the applications that can handle interruptions at any time, that save the data frequently. There's also a possibility to use spot instances with option of reservation for a period of up to 6 hours. In that case, the discount is up to 30% of on-demand. So still, if you have something that will make it within these 6 hours, it's worth to consider using spot instances. And also creating spot fleets, so that the capacity is provided by spot instances, but can also be backed up by on-demand instances in case there is no capacity left for spots. And now for the easy part, so reserved instances. I'm pretty much sure that everyone is quite familiar with those. So to keep it quite short, for steady workloads, can float across linked accounts within the same organization, which makes it possible to maximize the utilization of the purchased reserved instance. The account that actually purchased the reserved instance, so the one that paid for it, will always have the priority over the other accounts to use the benefit. Partial and all upfront fees are always charged at the moment of purchase, and then in case of partial and no upfront, next fees are always charged at the first day of the month. And what's important that if you purchase a reserved instance, no matter if you have any eligible instance to use it or not, you will always have to pay for it, no matter whether it's used or not. But then again, we got nice features to that, so instance size flexibility, and when it comes to RDS, deployment type flexibility, also again to maximize the savings. Instance size flexibility is for Linux EC2, and for RDS, MySQL, Maria, Postgre, and so on. That is a perfect solution if you have, for example, multiple projects in which the instance size can change. Thanks to that, if you, for example, purchase extra large reserved instance, it can either be used to cover the cost of extra large instance or 2 large instances, or even 4 medium instances. So that's a very good thing, but then again, it works the other way around as well. So if you have the extra large reserved instance, but you're running double extra large instance on demand, your array will cover half of the cost of on demand. Deployment type flexibility in RDS allows you to cover the cost of multi-AZ instances with single AZ reserved instances, and the other way around. So if you have multi-AZ reserved instance, it can cover the cost of 2 single AZ on-demand instances.
Would it be fair to say as a summary that if you do your reservation buys using your billing account, so that flows to the whole organization. And with this like a flexibility feature, it's quite difficult to kind of overbook your capacity or end up with the reservation that don't get used. Like in the old days, that was kind of relatively high risk.
Yeah, exactly. And quite recently, savings plans were released. It's still a new feature, very similar to reserved instances, because it's still about commitment, although how it works is a bit different. The savings are as follows. So compute savings plans can be compared to convertible arrays, and EC2 instance savings plans to standard arrays, especially when it comes to the savings. With compute savings plans, you commit to the to spending a particular amount of money per hour. But the thing to remember is that you're committing to the amount of to spend on savings plans rates. It's not the on-demand money, it's the savings plan rate. So you need to recalculate if you would like to check how much you need to commit to. Then again, compute savings plans automatically apply to any instance size, any family, tenancy, operating system. With compute savings plans, you also can cover the usage of Fargate. Furthermore, compute savings plans apply automatically across any AWS region. So you don't need to commit to reserved instance in particular region, but you can go for saving plan and cover the cost of on-demand instances in all regions at once. And when it comes to term and payment options, those are the very same as with reserved instances, so all upfront, partial, and no upfront with 1 or 3 year options. And yes. Savings plans do apply across all accounts within the organization. It can also be disabled exactly as reserved instances. So if you don't want to split it, then you can do that. And when it comes to cost allocation of savings plans, it's quite easy and simple, as along with savings plans, they received also separate charge types in AWS. So it's quite straightforward when it comes to cost allocation of which account used how much of the savings plan. Just to recap, they have great flexibility, savings quite as reserved instances, monetary commitment, not to the instance type, benefit to apply to all instances, regardless of family, size, or region. If you go for EC2 instance savings plans, you will have to commit to particular family and region, but instance type is of no matter in that case. And when it comes to the cons, then yet again, hourly commitment calculated based on savings plan rates. So if you would like to prepare a recommendation on your own, then you would have to recalculate your usage based on the savings plans pricing.
And these were like easy things to do in a sense that you can do this centralized, so you don't actually have to go to each individual development team and then tell them that okay you need to change your ways of working, and yet you can get quite significant savings simply by making the right size commitments. There are other patterns like I briefly mentioned earlier, like creating this kind of architecture model where you think that okay, yeah, I have my own role parcel, I have my application, and then I have my database to store the state of the session, and then you start repeating it, and suddenly it's not so feasible anymore. quite often you could refactor it into a model where you kind of share your front and data layer, but that's kind of introducing I would call it like an anti-pattern of public cloud, because the idea was that you can kind of break these dependencies between the teams, and that's how they can execute and keep their kind of level of deliverables in high quality. And then I'm now saying that, yeah, please go back to the shared database. It shouldn't be taken lightly, but sometimes it might be worth considering. Also, there are some more recent things like AWS App Mesh that could offer an alternative version to solve this like a service discovery problem that many people try to solve with the load balancers, for example, earlier. That would be much better fit for it, and also much cheaper to run. So like win-win in that sense. But nevertheless, yeah, these kind of changes the motivation must come from the development teams, because you cannot really force them, or you can try, but it doesn't usually work very well from top down. It's up to the teams to decide how their architecture will be, and with that, if you take that to the like an extreme, we see some activities, not that much yet, but some people are taking this like let's factor our servers away like totally, and like the title says, servers refactoring as no more servers to manage, so it doesn't imply certain frameworks or anything like that, but simply getting rid of the components that you manage yourself, whether those are like EC2s or databases or whatever, to the model where you actually pay per use. So that would be containers in Fargate or Lambda functions, and maybe Aurora serverless or Dynamo as your backend. This kind of things can be very difficult to justify in kind of financial terms, because I think I just heard the lady, I'm forgetting her name, from Lego, saying that they basically did this kind of refactoring, and it took like a year and a half for 20 to 40 people team to do. So it's like a 50 man-years effort roughly, and I'm sure you never will be able to pay back simply by like a lower running cost, but it has to be seen as a lower operational cost overall, and kind of technical debt payback all together, and then it starts making sense. Did I cover any of your next slide already? I hope I didn't too bad.
No. Just perfect. So the challenges of whole FinOps culture and optimization. So amongst others, cost allocation. It's quite an issue if for most of the companies, as different business units within the company, and everyone is pushing to pay only for what they use. And how to do that? Well, first of all, we need a cost allocation strategy. How to prepare one? It might be a process, quite long one, but then again, let's go first for an easy win. So if you're new to AWS, then it would be best to split applications on linked account level, so one account for one application. In that case, you will not need any cost allocation tags to allocate the cost further. It's the most accurate, easiest, and quite efficient, because with that being said, everything that's on this account was used by this application. But then again, it's just the first layer of the cost allocation. And it might not work for the current users of AWS. Later on, cost allocation based on tags. Well, it works, but isn't as accurate as we would like. Then again, because it requires discipline, it requires tagging every resource that you're running. Of course, it can be automated, but what happens when there are some changes, and sometimes some of them are done manually. So in that case, tagging needs to be fixed later on. Otherwise, we will not be able to allocate the costs properly.
Yeah, I would add to the tagging that the motivation actually has to come from the developers and the teams. So the tagging is a great tool for internally seeing like how our architecture is doing, but on a corporate level, please use the accounts for doing the cost splits.
Exactly. All right, and predictions and recommendations. So once we know what we are spending on, we can start with optimization and recommendations. So savings plans, reserved instances. Those are perfect and quite easy options to save some money. But let's first analyze and consult with all stakeholders if the application will run for as long as the array lasts, or saving plan. Otherwise, it may be left unused. So the things to remember about current usage, what we are already using. So if we have reserved instances that cover the cost of application of the EC2 instances, for example, then it's vital to remember that we cannot change the instance type. If we are using reserved instance to cover the cost of some EC2s, then savings plans will also not be applicable. Then again, there is also a budgeting issue, business development plan. So what are the plans for the future if we're going to grow, if we want to cut down on the cost of AWS? Those are all to be considered when we are creating a recommendation, when we want to purchase something or invest money in order to later on save.
Yeah, and then we have one example of how this might look in real numbers. So one take.
Yeah. So that's example from our customer. We created recommendations for EC2 and RDS array purchases, and as you can see, the cost went down. With EC2, not that much, but with RDS, the cost dropped almost half as much.
Yeah, and maybe the one takeaway from here is as well what's not in the picture. So you have your EC2 RI purchases and then some waste management as labeled as changing the infrastructure, but there's no like a cleanup for RDS shown in the picture. I think I would still argue that there could have been room for it without even knowing who this was and how they were running. But
might have been, but yeah. All right. So
yeah, as a summary, what we had here is always start with the low hanging fruit. So savings plans, reservations. There's very little excuse why not to do this. Maybe you need to have a little bit chat with your finance team, but still it can be applied easily without changing anything on a technical level. Waste management automation, so don't trust that people will look after their resources, but automate it. By definition, it should be fairly easy. In most of the cases, usually the problems would arise when you have this infrastructure as a code, and then you try to do some waste management, and suddenly your state is not in sync with the reality anymore. But most of the will result from the stuff that's not created through the automation, because the automation kind of dictates that there's automated provisioning, but there's also automated deprovisioning. If not, then you are kind of missing kind of critical piece in your workflow. Right sizing is another thing, getting slightly more complex as you need to have a data to decide is this right size or not. But once you have it, it's fairly straightforward, especially with the stateless components. Then kind of adding up the challenges in non-trivial stuff, but where the bigger savings probably lie is like replacing on demand with spots. So yeah, are your instances truly stateless? If yes, then please go ahead. Sharing the resources, like I explained, can be a bit anti-pattern, but then you need to judge, is this worth it, and finally kind of re-architecting your workloads into more modern architectures is never justified with simply the savings, but you have to think about like operational expenses and that technical debt you are paying back at the same time. And yeah, these things should kind of initiate from the development team side. With that, I think we are getting close to the time and lunch as well.